Good morning class, my name is Mr. Lewis and today we are going to be learning maths phenomena in music. Maths is what we call the language of science and music is what we call the art of science. Now the best person I can think of who married these together was Pythagoras, a long time ago in Greece, roughly around 520 BC. Now when he was at a blacksmith's, he noticed the blacksmith was hammering different types of metal. And every now and then what the blacksmith would produce is like harmonious tones. These harmonious tones is what we come to realise as harmonics. As an experiment, what Pythagoras did was he grabbed a piece of string, doesn't matter how long, and he'd tighten it on both ends and he'd pluck it and that would produce a note. Now these, once you got some weights, it would change the tone, and once he got about 2-1, which is halfway, he produced an octave, and that's the same note, just an octave higher. And when he got around 3-2, he developed the perfect fifth, or heard the perfect fifth. Now, what does this mean? Now, I'll prove this with my guitar. Just like Pythagoras, there was a note, a string, tensioned at both ends, and then exactly halfway, which is the 12th fret on a guitar, it produces that octave. Now an open is an E and a 12th fret is also an E as well. Now that perfect fifth, that 3-2 ratio is right here, in this case a B. So as you can hear, those two notes just marry up really well together. And if we jump into the future to Fibonacci, who was an Italian-born famous mathematician, which I'm sure you know of him for the Fibonacci sequence, the natural occurrence that he came up with, which matches these numbers here, like that. Just a quick refresher, we've got 1 plus 0 equals 0, 1 plus 1 equals 2, 2 plus 1 equals 3, 3 plus 2 equals 5, 5 plus 3 equals 8, and so on. And that's an infinite sequence of numbers. And what does infinite mean, everybody? That's right, it goes forever. Now, using these sequence, we'll just go to 13 because that's all there is within the Western culture and the chromatic scale here. If we take the 1, the 3, sorry, the 1, the 5, the 8 and the 13, we develop a major scale. Now, this major scale I'll prove with the C chord here, like that. Now that is a major scale, and this can be played all over. And back to where Pythagoras was, there and there is the fifth. Those two notes there is the fifth note. And some of the most famous songs you've ever heard or are learning to play now, for instance, will be using a major scale. While we're talking about famous songs, pop this away. Now the close relation to the Fibonacci sequence is we use phi. Now phi is when you divide the Fibonacci numbers, and once you start to get a little bit higher on, you get to 55.89. It will always be, when you divide, will always be within this range here, and if you get 55 divided by 89 is 0.61 and so on. And what we've got here is a large number. Now this large number is what we call the golden ratio. So this is where we're going to have a little bit of fun. Famous musician Gary Ewer came up with this theory. It's called the crescendo theory. Now he realised that about 61.8% into a song is when there's a crescendo, for instance, or a famous turning point in the song. And for me to prove this, I'm going to use one of the greatest rock bands ever that there ever was, Queen, and one of the greatest Queen songs ever written within the world, Bohemian Rhapsody. Now, Bohemian Rhapsody is roughly 6 minutes long. If you turn it into seconds, it's much easier. So if we go 6 times 60 is 360 seconds. Now 360 seconds, to find out about 61.8% into the song, we times it by 0.618, which equals 22.5 seconds. Now to revert it back to minutes, we divide it by 60, so 22.5 divided by 60 is 3 minutes and 8 seconds. Now, if I bring up trusty YouTube here, Bohemian Rhapsody, the song we all know and love. Now, what are the odds that if I skip to 3 minutes and 8 seconds, there'll be a turning point in the song? And I'm sure you already know what the turning point is. Let's start with 3 minutes and 5 seconds and 3 minutes and 8 seconds on the dot. Mind blowing, right? I know, tell me about it, me too. So, for your homework, what we're going to do is I want you to go home. And ask your parents what are their favourite songs of all time. And using the same formula as I used here is turn it into seconds by timesing it by 60, times that amount of second by 0.618, revert it back to minutes, and see where that high point is. And I'll guarantee about 75% of the class here will come back with it's dead on. Now, I'm not saying that musicians purposely made a song to 5 or to Fibonacci sequence like that. I just like to think that music should be natural, and there's nothing more natural than Fibonacci sequence. It's riddled all through through nature, so there's no reason why music shouldn't do it as well. So thanks for listening, and remember, maths plus music equals fun.